Hello friends, today we discuss about the transformer construction and working principle of the transformer. First of all, introduction. Now we all know that where the electric power generated and how the electric power transfer from generating station to the load. Electric power is generated by the large hydropower plant, nuclear power plant and steam power plant. All the power plant are situated very far away from the various cities, where you can say load center. Now normally the power generation is at the voltage level of 11 kV to 25 kV, and it is uneconomical to transmit the large amount of power over long distance because of large voltage drop and power losses. So what we have to do, we have to up the voltage. The transmission of electric power over long distance can be achieved economically when the transmission voltage is high. For that we have to use the step up transformer. By using the step up transformer we can up the voltage from 11 kV to 400 kV and so more. So the transformer plays an important role in power system. Now first of all we discuss the definition of transformer. Now what is transformer? A transformer is a static device which transfer AC electric power from one circuit to another circuit at the same frequency. From this definition we can conclude that first one is transformer is a static device and do not have any rotating parts. Second one is it transforms electrical power from one circuit to another circuit at the same frequency but at different voltage. Means frequency remains same, we can change the voltage level. Suppose if we use the step up transformer, then voltage is up. If we use the step down transformer, the voltage may be down but frequency remain same. And the third one is it operates only with AC and do not operate with DC. Transformer always works on AC power, not to DC power. Now symbolic representation of transformer. Here transformer consists of three major parts. First one is magnetic core, second one is primary winding, and third one is secondary winding. Now this one is the construction of transformer. This one is the core, which is made up of silicon steel. This one is the primary winding and this one is the secondary winding. This is the symbol of transformer: primary winding, core and secondary winding. Okay, here supply voltage V1, number of turns N1, number of turns N2 and load voltage V2. This symbol indicate the magnetic core. These two lines, straight line, it is the indication of magnetic core. Okay, in the transformer, primary winding is connected to the supply voltage and secondary winding is connected to the load. Okay, now we discuss the working principle of a transformer. First of all I introduce the circuit diagram. This one is the transformer core, this one is the primary winding having a number of turns N1, having a supply voltage V1, and this one is the secondary winding having a number of turns N2 and load voltage V2. Now what is E1? E1 is a EMF induced in the primary winding, and E2 means EMF induced in the secondary winding. Primary current I2 is a secondary current. Now the basic working principle of a transformer is a electromagnetic induction. Remember that the basic working principle of a transformer is a electromagnetic induction. In triple E subject we studied that Faraday's law of electromagnetic induction, Faraday's first law and Faraday's second law. These two laws are applicable in this transformer. Okay, we discuss in detail. It consists of two separate windings placed over the laminated silicon steel core. The winding to which AC supply is connected is called primary winding, and the winding to which load is connected is called the secondary winding. Now principle of operation. What happen when an AC voltage V1 is applied to the primary winding, the current I1 flow in the primary winding and produce the magnetic flux phi. Okay, this flux link with the both primary winding as well as secondary winding. Now as per the Faraday's law, self-induced EMF E1 in the primary winding is E1 is equal to minus N1 d phi by dt. Remember that Faraday's law, what happened? EMF induced E is equal to minus N into d phi by dt. Okay, from that here the equation E1 is equal to minus N1 d phi by dt, where N1 is equal to number of turns of the primary winding and d phi by dt is a rate of change of flux. Now the alternating flux linked with the secondary winding also through the laminated core, through the transformer core. So the EMF is induced in it called the mutually induced EMF. According to the Lenz's law, the direction of induced EMF is opposite to the applied voltage V1. That's why E2 is equal to minus N2 into d phi by dt, where N2 is equal to number of turns of the secondary winding and d phi by dt is equal to rate of change of flux. Okay. Now we discussed the construction of transformer. There are total 3 types of transformer: core type, cell type and Barry type. Here so in figure, core type transformer, this one is the core, this one is the primary winding, this one is the secondary winding. In detail, the vertical part of this core is called as the limb 1, and this one's limb 2. Okay, on that limb first we wound the LV winding, means low voltage winding, then high voltage winding. Low voltage winding is inner side of the winding and high voltage winding is outside of the winding. In the core type transformer, the magnetic circuit consists of 2 vertical sections called the limbs. This one is section 1 and section 2. Okay, and the horizontal section called as the yoke. The primary and secondary winding are provided on each limb. The low voltage winding is kept inside near the core, while the high voltage winding is placed on it. This type of winding arrangement in the core type transformer provide good magnetic coupling between primary and secondary winding. So the 2 windings are arranged as concentric coils. Such as winding is therefore called as the concentric winding, or you can say the cylindrical winding. The lamination for core type transformer are of U shape, I shape, E shape, L shape, etc. Okay, here we see that U shape. Okay, this one is the L shape, this one is the I shape. Okay, in most of the core type transformer, circular cylindrical coils are used because of their mechanical strength. While placing these coils, an insulation layer is provided between core and lower coil and also between the 2 coils. It should be noted that low voltage winding is wound near the core since it is easiest to insulate. If the high voltage winding is wound near the core, a heavy insulation will have to be provided to avoid the earth leakage. You can understand this, why the low voltage winding is kept inside the, or you can say nearer to the core, because if we use the high voltage winding to near the core, then we have to provide the high insulation layer between the core and winding. That's why we put low voltage winding near the core. Okay, now advantages of this core type transformer. First one is natural cooling is more effective. Second one is construction is simple, and third one is the coils can be easily withdrawn for repair. Second type is cell type transformer. Here so in figure, in this cell type transformer there are 2 windows, Windows 1 and Windows 2. Here 3 limb, 1, 2 and 3. As shown in figure, low voltage winding and high voltage winding, both the winding are wound on the central limb. Okay, in the cell type transformer, both primary and secondary winding are wound on the central limb and the two outer limb complete the low reluctance flux path. Okay, winding are normally of sandwich type. See that here LV, HV, then LV, HV, then LV. This look like a sandwich. That's why it is called as the sandwich type winding. The top and bottom coils, which are near to the core, are of LV winding. Okay, the lamination for cell type transformer is made up of either U section and T section, or you can say E section and I section. See here, E section and I section. Okay. Advantages: first one is better mechanical protection to the winding. Here winding inside the core. That's why the mechanical protection of the winding is more than the core type transformer. Disadvantages: natural cooling is poor. The coil cannot be easily withdrawn for repair. Suppose if any fault occurs in the HV winding, then what we have to do? We have to remove the hole, open the whole transformer. Then first of all we have to remove the LV winding, then we have to remove the HV winding. And in core type transformer, primary winding and secondary winding both are on different limb. That's why if the fault occur on secondary winding, then we have to replace only the secondary winding. Okay, in that view, the coil cannot be easily withdrawn for the repair. And third one is Berry type transformer. This type of transformer having a multi-magnetic path is known as the Berry type transformer. Due to this construction, the Berry type transformer has distributed magnetic circuit. The low voltage winding placed inside and the high voltage winding placed outside as shown in figure. See here, low voltage winding is inside and the high voltage winding kept the outside. Okay. Now we discuss the comparison of core type transformer and cell type transformer. Now in core type transformer, a considerable part of the core of a transformer is surrounded by a coil is known as the core type transformer, and in cell type, a considerable part of the winding of transformer is surrounded by a core is known as the cell type transformer. Second one is LV winding and HV winding are normally distributed over two opposite limb of core. Means both the winding are on two different limb, and in cell type transformer both the winding are wound on the central limb. Winding are of cylindrical type and winding are of sandwich type. More suitable for high voltage transformer and more suitable for low voltage transformer. Mill length of coil turns is shorter, mill length of coil turn is longer. In core type, core is either circular or rectangular. In cell type transformer, core is either rectangular or cylindrical or spiral in shape. In core type transformer, it has only single magnetic circuit, and in cell type transformer, it has a double magnetic circuit. In core type transformer, core has two limbs, and in cell type, core has three limbs. In core type, the coils can be easily removed from maintenance, and in cell type transformer, the coils cannot be easily removed for maintenance. Okay, so this is the comparison of the core type and cell type transformer. Okay, thank you.